Day 45, page 935, problems 6 and 7. I have them all laid out here, partly because drawing on this iPad is a little tricky. But anyways, let's get used to the terminology here. When it says we have a positive lens, that means a converging lens. Also in number 7, it says convex lens, same thing, it's a converging lens. On the AP test, it'll say it's a converging lens, or they'll have a diagram showing you the type of lens it is. The converging lenses bring light together, they're thicker in the middle, and these are two similar problems in which we will be using the lens equation 1 over focal length equals 1 over object distance plus 1 over image distance. I'm using S sub O for object distance and S sub I for image distance. So as we went over in class, when you have an object that's a ways from the lens, the farther away the object is from the lens, the closer the image is to the focal point of that lens. And I've drawn in the first diagram, number 6, two of the principal locating rays, of which you could draw millions, but 3 in particular are useful. I didn't draw the third one there in the first diagram, the one that goes from the object through the center of the lens, essentially undeviated. And that diagram I drew is fairly accurate. And in the calculations, you get the image distance as 15 centimeters positive for a real image. Both of these are real images. They're upside down. As long as your object is beyond the focal length of a converging lens, you will get a real image. And then you'll see number 7, as you bring the object closer in. For some reason, I have a bigger object in this case. It didn't really matter. I could have started with the same size object. But in number 7, the magnifying situation, the image is real again, it's flipped, but your object is closer to the focal point, so your image is beyond twice the focal length and large and flipped. So I didn't draw the third ray in that case, the one that goes through the focal point, and my diagram number 7 is a little bit out of scale. You can see because by calculation the image distance should have been 150, a lot closer to the 2F location than I have here. And I also did the magnification. I messed it up once and I couldn't erase it for some reason. In number 6, if you had to find the magnification for real images, they're always negative because that means they're flipped. In the first case, it's less than 1. It's shrinking the image. And in number 2, it is bigger, but negative, and it's flipped once again. So if they asked you for the nature of the image, you would tell whether it's real or virtual. In this case, they're both real. Their locations, as I have by the calculation or the diagram, and then their magnification.